In this lesson, we estimate cache misses for a streaming loop. A loop strides through a 32 megabyte array with 64 byte blocks on an 8 kilobyte direct mapped level 1 cache. We will do 5 passes and decide which miss type dominates. First, compute 2 key counts. The number of blocks in the array is 32 megabytes divided by 64 bytes, which equals 524,288 blocks. The number of cache lines in the level 1 cache is 8 kilobytes divided by 64 bytes, which equals 128 lines. Here is a small picture to guide our intuition. On the left is a tiny sample strip representing the very long array. On the right is a sketch of the direct mapped cache with 128 lines. The loop strides forward, one block after another. Each new 64-byte block maps to exactly one of the 128 cache indices. Because the array is far larger than the cache, we never reuse a block within the same pass. Reuse happens only on the next pass, after touching all 524,288 blocks. On the first pass, every block is touched for the very first time. Those are compulsory misses. So, first pass compulsory misses equal the number of blocks, 524,288. What about passes 2 through 5? By the time we return to any particular block, we have streamed through the entire array. The reuse distance is 524,288 blocks, but the cache holds only 128 lines. That block cannot still be resident. So every access in passes 2 through 5 misses due to capacity. Are there conflict misses? In a direct mapped cache, conflicts happen when 2 live blocks map to the same index and evict each other before reuse. But here the working set is enormously larger than the cache, and we do not reuse a block until the next full pass. Even a fully associative cache of the same size would still miss on every access in passes 2 through 5. So conflicts do not add misses beyond capacity here. We count conflict misses as essentially 0. Summary: for 5 passes, compulsory misses 524,288 from the first pass. Capacity misses 2,097,152 from passes 2 through 5. Conflict misses approximately 0. Capacity clearly dominates. Intuition: streaming exceeds the cache footprint. Each new block pushes out old ones, and we do not come back soon enough to benefit. That is why capacity misses dominate for large, sequential scans.